So hello students, welcome back to our video classes. Good morning, good evening, good afternoon, whenever you are watching it. So the thing is, today we would start with the first chapter of class 9, which is matter around us pure. So this is the first video. So I think today we would start with the metals, non-metals and the metalloids. This chapter is the most relevant chapter of class 9 because here you can see in front of you there is the periodic table, and here you are going to learn about the entire periodic table. In class 10 you would be learning about this periodic table in more details, but let me tell you, as you know, there are so many elements in our universe, and among them there are mainly, they have been divided into mainly three parts. One is a metal, another is a non-metal, and in between them there is a metalloid. In this chapter we are going to learn what is called elements, what are the things, those are called molecules and compounds and all these things. And apart from that, we are definitely going to learn about the few details about them as well, the metals, non-metals and the metalloids. In today's class we are going to mainly focus on the metal, non-metal and metalloids. Apart from that, we are going to learn about the molecules, the compounds, the elements and all these things together. Today we have some few cool videos as well, so please give your 100% attention to these videos so that you would be able to learn everything. Okay, now the thing is, if you have any doubt regarding all these things today we are going to discuss about, what you have to do is you just have to write it on our forum. Okay, and definitely one of us would definitely reach you. Okay, I think we're all set to go. Now today we will start with the first topic. You can see over here, let me just give you some introduction about it. So you can see that in this the first part, where what the picture you can see in front of you, this is the periodic table, and you can see there are so many colors in it, isn't it? The red colored things, all the red colored things over here, they are all metals, all the red colors. So there are near about, you can see like more than 90 metals in this periodic table. So most of the periodic table is red, right, isn't it? So most of the periodic table is a metal, now consisting of metal, isn't it? So now if you just see the yellow part, you can see over here it is written, the yellow parts are the metalloid. I'm going to tell you what are the metalloids, and the blue parts are the non-metals. Now the thing about it is, you can see all the metals are staying together, while all the metalloids are staying together, and all the non-metals are also staying together, but only there is a non-metal which is hydrogen, which is over here. So we are going to learn that as well, why hydrogen is over there. Okay, now let's start with it. So today the topics covered would be, what is a pure substance, what are the elements, and the classification of elements, like the things I was trying to tell you: metal, non-metal and metalloids. Okay? So first we need to learn the thing is, what is element first. After that we would go into details. So first we need to learn a few things. First, I think we would start with the atoms first. Okay, so what are the atoms actually? You know that if this is a building, okay, if this is the World Trade Center, so I think you have heard that in the world, you have seen as well, right? In World Trade Center, so it was, I think you know what happened to World Trade Center, right? So basically the thing that happened is, there was an airplane. So I'm trying to draw an airplane. Okay, you know what, I draw pretty well, you can see, isn't it? So an airplane just hit the walls of World Trade Center, and so many, there are so many things, like there was already some bombs were there and all these things. Okay, I'm not going to the controversies, right? The thing is that when the airplane hit the World Trade Center, it just broken down into pieces. So the thing is, actually there was a scientist inside that airplane who was trying to figure out what is an atom. Okay, so actually if you just try to break anything up, okay, if you just try to break anything up into the smallest possible pieces, you would end up in the atoms. So what are the atoms? So the atoms are the constituent smallest constituent of a matter. So whatever you see surrounding you, everything is made up of atoms only. Fine. Wait for a moment. Yeah. Everything is made up of atoms only, and the smallest entity of every matters are called the atoms. Fine. Now there are so many, this is just the beginning of this part of this conversation. So definitely if we just go on, we would be able to understand what is an atom actually. So I think you know about it, but still there are some confusions that getting created about the atoms and the elements. So what is the difference between an atom and an element? So let's just try to consider that this is you, okay, and this is your first class over here, okay. So right now we are doing the classes online, but just think that you are there in the offline classes. Fine. Now the thing is, you are there in your school. You have gone to your school. You have a bag like this. Fine. And a cap. Okay. So you're going to your school and you have met so many friends there. Okay. You have met so many people like you only, but you don't know them. So far, you don't know them. Right now, all of you are sitting in a room. All of you are in a room of class 9, isn't it? So this thing like about 40 to 50 students are there in class 9. Okay, all of you are sitting in there. Now the thing is, you are an atom of that class. You are an atom of that class because you are the building block of that class. You are the smallest constituent of that class. I'm not talking about the building. I'm not talking about the school building. If that was the school building, then the bricks are the atoms. I'm just trying to tell you how this thing happens. What is the atom? I'm just trying to make it clear to you. These are the bricks, okay? When the bricks gets attached with each other, they make the building, isn't it? They make this types of buildings, right? So these bricks are the atoms of the entire building. And if you are trying to think about, I'm just trying to make everything clear to you with one example only. For that reason, just consider that you are there, you are going to the school, and in the class 9, what is the building block of class 9? You are the building block of class 9. You are the smallest possible unit of class 9, right? You are one student of class 9. So you are an atom. Fine. Now, there are so many atoms like you only. All of them have combined together to make this class 9. Fine. All of them have combined together to make this class 9. Now, this class 9 is called, this is called an element. Just think about it. This is the first day in your school. Okay. Now you have gone to your school, the first day in your class, you don't know anyone, and you are the atom, and together, all of you are together making this class 9. Class 9 is an element. So let me show you something. Like, consider that this ball over here, this is an atom. Okay, this ball over here is an atom. Okay. Now, if I just combine all these type of balls together, you can see there are so many balls inside my hands, right? So how to show you this? So like this. I'm just trying to show you like this. Just look into it. You can see so many balls in my hand, right? Black colored balls. Okay, I'm just trying to hold them up. Okay, you can see like this. So they all are making this, like this thing is an element. All these balls together is an element. Fine. But one ball is an atom. Okay. So now what I mean to say is that one guy over there is an atom, and together all of you are making the element. But the cool thing about it is that the symbol of the atom, the symbol of an atom and the symbol of an element is just the same. Both are just the same. That is where we get confused. Look, this is just like, let us just take an example. You'll be able to understand. Let us just consider that we have, so this black ball over here, this is carbon, okay? Carbon, black carbon. So let's just consider I have carbon, okay? So now this carbon over here, what is this? This is an atom, isn't it? One is an atom. Together they are element. So one ball is an atom. Now let me tell you what is the size of an atom. The size of an atom is near about 10 to the power 9 meter. We also call it 1 nanometer. Okay, this is the size of an atom. Now if this is carbon, this is atom, this is of 110 to the power minus 9 meter. So do you know what is graphite? Do you know what is diamond? Or have you ever heard about fullerene? All of them are nothing but carbons only. So they are just like this. So all the carbons are together to make a compound, not a compound, so together to make an element, which is nothing. So the main thing is all of them have the symbol of C only. And the carbon atom is also C. So it's like these things are made up of carbons only. So what could be their symbol? That is C. And this atom is also made up of carbon. So not made up of, the atom is carbon. So that is the thing over here. So the atom is the smallest possible unit, and the elements are, they are just together. They are just together like the class 9. In class 9, 40 students are together. So that is an element. That is an element. In graphite, diamond, fullerene, there are near about 290, 390 carbon atoms together to give you this graphite, diamond, fullerene type of structures. So they are just the elements, right? Got it? Now that was your first day over here, right? That was your first day. You don't know each other. This is the first day in the school. You don't know each other. You are an atom, and the entire class is an element, right? Got that part? Now we are moving to the next point. Now, if you have understood up to this level, then now if I say after 2 months, what would happen? After 2 months, what would happen to the entire picture? So the thing that would happen is you would make new friends, right? You would make new friends. So this is you. You are having a new friend over here. Okay. And I think there would be some other groups as well. So you'd make groups, like there would be another group of 3, maybe 3 friends together. They would holding each other's hands like this. Okay. There can be another group. So they have made new friends, okay, over there. After a couple of months, definitely you would make friends, right? Yeah. Okay. I draw pretty well, isn't it? Okay. So these are the groups. These are the groups. Now they are friends. Okay. They are friends. Now there comes a twist. So now they're friends. So what would happen is they would always stay together. They would go to the ground together. They would go to the market together. They would go to eat together. Wherever they would go together. So when that was the first day in your school, you was an atom. But now you have a friend and you are holding each other hands. So you are not an atom anymore. So what are you now? So let's try to think about it. So this was you initially. But now you have some new friends and they are holding your hands. This guy over here, he had made 4 friends. And you can see now it is holding 4 friends' hands, right? You can see 1 and 2 and 3 and 4. So this thing has 4 friends now. Okay, they are holding each other's hands now. This is a friend and this is a friend. They are holding each other's hand with the stick. Okay, now this thing over here is not a atom anymore because they have made new friends. They are together. So this thing is called a molecule. So when the atoms reacts with other atoms, they forms molecules. So now all of you are molecules. This is another molecule. This is another molecule. Let's take an example. If carbon is an atom, okay? If carbon is an atom, if carbon makes friendship with 4 hydrogen atoms, together they would make this compound only. We call it methane, right? We call it methane. So this is this compound. The compound I showed you just, this one only. So this is methane. This is how it looks like. Fine. So this thing is methane, and you can see the same thing I have drawn over here. Now this is over here. You can see there are 2 types of atoms. They are holding each other's hand. So this is called a molecule. Got my point? So when the atoms are reacting with other atoms, they are making molecules. Fine. So now if you just look into it, they are saying that this is an atom. The red guy over there is an atom. Now when this red guy is making friendship, 2 red guys are making friendship with a blue guy over here, that is a molecule, you can see. Okay, that's a molecule. So let me show you what is there actually. So the thing you can see over there, that is nothing but water. What about water? Definitely yes, right? So this is how water looks like. This thing. So basically this is the oxygen. You know the formula of water, isn't it? H2O, isn't it? So this is the thing, oxygen and 2 hydrogens over here. So this is H2O. So this is how water looks like, holding each other's hands, right? So now what is this? This is a molecule. If someone asks you, in water molecules, how many atoms are there? What would be your answer? Your answer would be 5 atoms, isn't it? 3 atoms. 3 atoms. What are the atoms? 2 hydrogen atoms and 1 oxygen atom. Similarly, in methane, there are 5 atoms. Fine. So 4 hydrogen and 1 carbon. Together they're making 5 atoms. Getting it? Getting it? Clear? Now, water over here is a molecule. This thing over here is a molecule. Okay. Now wait for a moment. Let me show you something. So like the atoms are the individual thing, like this is an atom, okay, and this is an element together, all of them. This is an element, okay. We cannot see an atom, but we can see an element because the atom is so small we cannot see it. But in case of elements, all the atoms, when they are together, the thing is we can see them together. Okay, now because they are making a big structure like diamond, we can see diamond, we can see graphite, we can see fullerene, we can see charcoal, we can see coke. All of them are allotropes of carbon. Like all the carbon atoms are together, they are making that thing. Got my point? Now the thing is, This was water, isn't it? Just give me a moment. Let me show you something. So like atom was the only one, and when all the atoms are together, we were calling it an element. Similarly, when there is only one water, that is a molecule. But when there are so many water together, you can see 3 water molecules over here, so it's very difficult to show. Like this, I think you can see. Yeah, through 3, and I can make so many more, right? Okay, just forget about it. I'm getting my point. When all the water molecules are together, we call it a compound. So let me clarify these things to you. Atom was 10 to the power minus 9 meter. It was very small. Think about it. 10 to the power minus 9 meter. Point after that, 90 after that 1. Okay, 10 to the power minus 9 meter. It was very small. Now think about it. You need to, imagine yourself there. Now you are an atom who is 10 to the power minus 9 meters small. Now you are making friends with other atoms. They are also 10 to the power minus 9 meters small. So together, one oxygen is making friendship with 2 other hydrogens, and together they're making water. Okay. Now that is a molecule. So what could be the possible size of a molecule? They are about 10 to the power minus 9 only, isn't it? What can be the possible size of a molecule? If 3 10 to the power minus 9 meter substances combines together, it would be something at about 10 to the power minus 9 or 10 to the power minus 8 meters. That can be the order, right? But think about water. Water is a molecule, and it is of this radius, okay, this size. But we can see water. How can we see water? Because there are so many water molecules together in there. Okay. Now, when there are so many water molecules together in one place, they are making big structures, and that is not a molecule anymore. That is a compound. Now, to make it clear to you, make everything simpler to you, whatever we have read, the thing is, atom is a singular number. Element is a plural number. When one atom is there, that is atom. When so many atoms are there, that is element. Both of them have the same unit. They have same symbol. Okay, atoms and elements. Now, similarly, for molecules, what are the molecules? When 2 or 3 atoms combines together, when they make friends, that is a molecule. Now, when the molecules are together, so molecule is a singular number, but compound are the, like all the molecules are together, that is called a compound, and compound is a plural number. So, have we got it? Everything clear? So, that was the thing about it. So now look at this picture. This is an atom. But when this atom is making 2 friends, that is a molecule. Now, this is another molecule. And you can see this is also a molecule. So here is something new you can see. When the 2 atoms are same, that is also a molecule. Like, let's consider this thing is hydrogen. Okay. So this is nothing but hydrogen molecule, H2. Fine. So this is over here, this is H2O. 2 hydrogens and 1 oxygen, and here you can see 4 here 2 atoms are different and 2 atoms are different, so you can think of anything like that. Okay, so this can be like 1 2 3 4 structures are there, 4 elements are there. This can be like N H H Cl, something like this, anything. Okay, so this is another molecule. So molecule can be made up of same elements, same atoms, or molecule can be made up of different atoms. Okay, so that was the thing about the molecules and about the atoms. Got it so far? Okay, fine. So if I ask you this question, what is the smallest unit of a matter? What would be your answer? Definitely it would be atom, isn't it? Atom is the smallest unit of matter. Okay, what is the smallest unit of an element? That is also an atom, isn't it? So this is element. Element is the plural number, and one of it is atom. Now, what is the smallest unit of a compound? So this is compound, isn't it? This is compound. Now, this is a molecule. So compound, a unit which contains all the properties of a compound is nothing but a molecule. Fine, fine. Got it? So I think we got that far, everything. Okay. Now we are going to learn about the substances. So in this picture over here, so you can see this is a molecule and this is a compound. So this, if this is the molecule, then this is the compound. Okay, fine, fine. Look into it. Clear? This is the compound. Now the thing is, sorry, white won't help me, right? Because the screen is already white. So let's just take something like yellow over here. Would I be able to see yellow? No. Give me a moment. Fine. Now the thing is, what is a mixture then? What is a mixture then? So mixture is something like when I'm, one molecule is this, another molecule is this. When I'm mixing them together, what is a mixture to you? When I ask you to tell me an example of a mixture, what you do is you just tell me like if I just mix salt and water together. So it's like two molecules or two compounds are being mixed together. Okay, or more than two can also happen. So when two or more than two compounds or molecules, just write it. So what is mixture now? Okay, so when two or more than two molecules, or you can also write molecules or compound, okay, or compounds are mixed together, okay, then we call it a mixture. Fine, that is the example of a mixture. So like if I just mix salt and water, that is a mixture, because water is a molecule, salt is another molecule, salt is NaCl, water is H2O. So there would be two types of molecule in that thing. So these type of things are called binary mixture, because bi means two, isn't it? So it is called binary mixture. Fine. So when there are three things are mixed together, so let's just consider I have salt, I have some sugar, and I have some water. All these three things together. So salt is NaCl. Apart from that, sugar is C6. Okay, it is sugar, right? C12, H22, O11, and this is water. When these three, so there are three types of molecules, isn't it? This is a molecule. So this is another molecule, and this is another molecule. So there are three types of molecules in there, and when we are mixing them together, we are getting a mixture. Got my point? So in a mixture, there can be so many types of compound in it. So compounds or molecule in it. So you can see like this thing, all the different types of molecules are mixed together. All of them are together. Okay, this is called a mixture. Fine. So if I ask you which one, compound or mixture, which one is pure? What do you mean by the word pure? Pure means when there is only one type of molecule, isn't it? Pure means only one type of molecule. What do you understand by the word? If someone asks you pure milk, so there is only milk in it. There is no such water. Pure means there is no such adulterations inside it, isn't it? So there should be one type of molecule. So if water contains only water, that is a pure water. If water contains water and some else foul particles inside it, we cannot see the color, isn't it? You see? Yeah, here. So just saw the color, isn't it? It's not showing it. Green? Yeah, green. Okay. So if it contains water and this molecule over here, if they are together, mixed together, then we call it impure water, isn't it? Okay. So pure water means only water molecule. So if there is only one type of molecule, that is called pure. Got my point? Now, which one is pure? Definitely compound is pure. Because in compound, there is only one type of molecule. But in the mixture, this is going to be impure. Tell me, is it clear to you? We are needing chemistry, right? I think you got it. Now, the thing is, now pure substances. Pure substances. What do you mean by pure? I'm just writing it over here. When there is only one type of molecule, then only we call it pure. Okay, when there is only one type of molecule, then only we call it pure. Now you can see that if we talk about pure substance, how many types of pure substance can be there? Elements and compounds. I think you got the point, difference between elements and compounds, right? Element contains only atoms, one types of atoms. Okay, compounds are containing different types of atoms together, chemically bonded together, forming molecules, right? I don't want to make confuse you anymore. Got it, everything, right? Now elements are of two types. Okay, you can see atoms or molecules. So you can see if we talk about neon, so this is made up of so many neon atoms, isn't it? So that is an atom. So that is, all the things together, they're making an element. Okay, now you can see over here, this is O2. Okay, so this is a molecule over here. Now actually the thing is, right now in this picture, the thing is, a little bit confusing. So what I mean to say, what they mean to say over here is, there are some few types of particles. For them, a molecule and the atom is just the same. Let me show you one. Don't get confused over here looking at those things. Just think about one example. Okay, take hydrogen. So tell me, what is the symbol of hydrogen molecule? What is the symbol of hydrogen molecule? You definitely say, sir, this is H2. Okay, so basically two atoms of hydrogen are mixed together, are making friendship with each other to make a hydrogen molecule. Each one of them are hydrogen atom, isn't it? Give me a moment. Each one of them are hydrogen atom. Fine. But then for hydrogen, this is an atom and this is a molecule. So for that reason, what do we call it? What do we call hydrogen? We call hydrogen a diatomic molecule because two atoms are there. Diatomic species, we can also say a molecule. Okay. Diatomic species, or you can also say. Fine. Okay. Now, this is called a diatomic molecule. Now, the thing is, so if I just think about, give me a moment. Just give me a moment. So this is hydrogen molecule. You can see two atoms are making friendship with each other. That is a molecule, diatomic molecule. Got my point? Okay. Now the thing is, over here, if you just come back, now the thing is, if you just look into a diatomic molecule, so if you just look into the other example of it, so if I just take For an example, if I just take let's just take one example of, you say, let's take argon. Okay, argon as an example, or carbon as an example, or helium as an example, or neon as an example. If you just take any one of them as an example, now tell me, if I ask you, what do you understand by the word, if I just say argon atom, what would be its symbol? What would be the symbol of argon molecule? Tell me. Actually, what happens is, for argon atom, the symbol is Ar. For argon molecule as well, the symbol is Ar. So the thing is, argon, so there is no such difference between argon atom and argon molecule. They are just same. So argon, so for that reason we call them monoatomic species, or you can also say monoatomic molecules. Clear? So that was the thing. So for monoatomic species, for monoatomic molecules, molecule and the atoms both the same, both are just the same. If I ask you now this question, if I ask you, what do you understand by the word argon element? So you know it already. Argon atom and argon element would have the same formula. But what can be the formula of argon compound? That would be also be Ar only. Getting my point? So argon molecule, argon atom, argon compound, argon element, all of them is having same formula. So that was the beauty of it. So for that reason only, sometimes may get confused about it. So for monoatomic species, there is no such difference between molecule, atom, compound, or element. All of them would look the same to you. Fine, got my point? Now, that was the thing they are trying to tell you. So what would be the form? What would be the example of a pure substance? So if someone asks you, give me an example of a pure substance. So you would be giving an example of an atom. You can say that any atom. You can take name of any atom. Fine. You can take the name of any molecule as well. You can take the name of any compound as well, or you can take the name of any element as well. All of them are just the same. So all of them are pure. But you cannot take name of any mixture, because in mixture there are two different types of molecules. So that is an impure. So you can see this thing, CO2 or H2 over here, they can be molecule or compound. We don't know. CO2 and H2 both, they can be molecule or compound. They are pure. There is no such, in CO2 there is only CO2. There is only CO2 molecule. In water there are only water molecule. In graphite as well. So this one is diamond. In diamond, this is made up of carbon only. This is made up of carbon only. But what is this? Is it a carbon element or a carbon atom? It is a carbon element. So these are the things you need to understand. Fine. Are we clear with it? So you can see this chart for your reference. So I think we have cleared this idea about atom element. So what is an element? So element is the nothing but like it is a plural. Just remember like that. This is the plural. Okay. So this is nothing but when all the atoms together, they makes the element. So boron over here, this can be atom. And when so many boron atoms are together, they are making it an element. They're making it an element. Okay. Now, we would start the next part of this video. So you can take a break over here. Okay, you can take a break of 5 minutes and you can come back, and there we would be discussing about the metals, the non-metals, and the metalloids. Fine. So you just take a quick break of 5 minutes and just come back, pause this video and just come back. Okay, so I think you have taken your break. Okay, so this is the second part of this video. Now what you have to do is, now we will start the second part with a small video. Let's see it. So right now they have started this video in a very interesting way, isn't it? You can see they have shown you some smartphones. So right now they are going to make you understand about this metal, non-metals, and the metalloids via using a smartphone. It means as an example. Okay. So what are there inside the smartphones, and how there are metals inside the smartphone and how they're helping you. They are in that way they are trying to make you understand about all the properties of metal. Let's see. So I think this is self-explanatory, isn't it? All the pictures over here you can see. So this is the thing about smartphone right now. You can, that they have sensors which are, touch screen sense, making it touch screen and making it smarter, isn't it? But what is behind it? Why the sensors are working like that? Okay, here we are going to learn that. Okay, so none of this without chemistry, none of this would have been possible. You can see they are starting with another periodic table over there. So about 90 to 91 elements are metals. Okay, and 20 of these are made, used to build your phone. So these are the properties of metal. We are going to look into all these properties in details, but right now just go through the video first. You can see the luster, malleable, solid, conductive, ductile, tensile strength, high tensile strength, high melting and boiling point. We'll be discussing about all of these in details one by one. Right now they are just trying to give you an example. So this is what luster is. You can see their shiny appearance. So you can see your smartphone is a little bit shiny, isn't it? From the back. So that is called metallic luster. Okay. So right now they have shown you something a net-like structure. So that is what metals can make. So metal can make this small, this type of net-like structure, which is increasing the durability of the smartphone. So if it falls from your hand, it would, get scratched, but it would not break. So that is because of it is made up of metals, and the metals have high tensile strength, high durability. So they are strong and they are malleable as well. So you can change the shape of a metal by just heating it and by hitting it. Okay. So that way you can give it a shape. Now, how can you make it touch screen? Because in there are some, I should rather say there are some, semiconductors, but you would learn that in physics. Right now, the thing that I can say is there are metals only. Metals or metalloids, you can also say. Anyways, there are metals only for now. That metals are conductor of electricity. That metals are the conductor of electricity. For that reason only, you can, make the sensors. The sensors, all the sensors are just made up of metals only. Fine. So the screen is containing a thin glass over here. Okay, that is a polymeric metal structure. Right now, they are trying to say is, so there is a like electrical charge falling through the phone, and when you just try to touch a particular surface, sorry, when you try to touch a particular surface, what happens is the like the thing that what I mean to say is the sensor, they sense it. Okay, all these things they're trying to say, but right now we are focused on the metals, non-metals only, right? So all these things are like transmitter on this, all these things they're trying to show you. It's this processor is just like our brain, isn't it? So like it just takes up all the signals and it gives and after that it gives out all the signals right there. So the processor is just like that. That's how you can show, you can see different type of things. Now these are about the metalloids. Like metalloids have luster, not malleable, non-durable. So you know what? Now they're going to show you the different type of things about the metalloids and the non-metals as well. But it is better if you just go on slowly with that, isn't it? So the first thing is classification of the elements. So you can see, just give me a moment. White is not getting good in here, right? So classification of elements. Elements are mainly of three types. So what is element? I guess you got it. What is element? So in periodic table, there are so many elements in there, isn't it? So metals, non-metals, and metalloids. So these are the three types of elements inside it. Okay. Now, so this thing over here, this thing is an element. Okay. Now there are so many. So this is an atom, and together they're making element. There are so many elements inside the periodic table. Fine. So these elements are classified as metals, non-metals, and metalloids. Okay. Just wait for a moment. Yeah. So the thing I was saying that was a metal, that was an element, and there are three types of elements in a periodic table: metals, non-metals, and metalloids. Fine. Now the metals are, you can see, metal is a solid material which is typically hard, shiny, malleable, fusible, and ductile with good electrical and thermal conductivity. So there are so many things together, right? So you can see that the first thing is it is hard. So if you try to change the shape, if you try to change the shape of a metal, it would prevent you to do that, right? So the tendency, so what do you mean by hard? What do you mean by hard? Or like, what the thing about it is, it means the tensile strength. Okay, means the tensile, it means the tensile strength. So what do you mean by that? When you try to change, when you try to change the shape, it would prevent you to do so. So the ability to prevent you to make any change in shape of that particular substance is called as tensile strength. So for metals, the tensile strength is high. So for that reason, we call it hard. What do you mean by the word shiny? So the thing is, metals are shiny means metals are also called lustrous. Okay. Which means it has a shiny appearance. So I think you have seen that all the metals have a shiny appearance, right? You can see the picture over here. So this is aluminium, silver. This is silver. So silver is lustrous, shiny. This is gold. Okay. This is silver. This is copper. All of them are lustrous. All of them are shiny. They are malleable. What do you mean by the word malleable? Let me show you. The word malleable means, so you can beaten when a metals are beaten into sheets. Okay, they are beaten into sheets. So when we can beat a metal into sheets, that is called malleability. So I think you have seen that we give shapes to metal objects, isn't it? Think about it. All the things in our house, all of them are made up of metals, and they have different types of shapes as well. So the metals can be beaten into sheets, or you can change. If you just hit it, it would be beaten into sheets. Okay, let me tell you the the most malleable metal. The most malleable metal is gold. So gold is the most malleable metal. Okay, no. So you know what? You can make gold foils. You can make gold foils. You can make aluminium foils as well, isn't it? You have seen the aluminium foils as well. So gold foils, aluminium foils, so they are, you can make them. So for that reason, these are the properties of metal. Apart from that, they are also ductile. So what do you mean by the word ductile? Tell me. What do you mean by this word ductile? So the ductile means, the word ductile means they can be drawn into wire. Okay, they can be drawn into wire. So I think you have seen like copper wires are there, tungsten. They can be like tungsten is not a wire. You can make filament with it, right? You're getting my point. Copper wires are there, so they can be drawn into wires. So for that reason, we call it ductile. What else? What else is written? There should be conductive, good electrical and thermal conductivity. The last thing is conductivity. What do you mean by this word conductivity? So they can conduct electricity and heat. What do you mean by that word? Conduct what? Electricity and heat. What do we mean by that? So when a particle is conducting electricity, that means, I think you have heard that, you have seen there are conductors in bus. Okay, I think you have seen buses, and there are, in the doors there are conductors, right? So what are the works of these conductors? So these works, okay, you can see like how good I am I right with drawing? So I'm very good with drawing. So the thing is, you have seen like the conductors are there. Okay, they look like this. Okay, it's fine. Now this is the conductor. What is his work? He conducts the entire bus to one place to another place. Similarly, the metals, they conduct electricity and heat to one place to another place. I think you know that all the wires are made up of copper. Okay, why? Because copper is a very good conductor. Metals, all the metals are very good conductor. They can conduct heat. They can conduct electricity. Okay, fine. So that was all about metals. Now, if you just look into the non-metals, so yeah, here there are non-metals. So what are the non-metals? So non-metals are like metals. If you just put a non over here beside it, that is a non-metal. So whatever we have learned about the metals, just put a non beside it. Okay, that would be the properties of non-metal. So this would be, they are brittle, they are not hard, that is called brittle. Okay, they are not malleable, they are not ductile, they are not a good conductor, they are poor conductor of heat and electricity. So everything you just write not over here, so you'll be able to find the properties of non-metals. But yes, there are exceptions as well, right? There are exceptions. Like if you just think about, they are non-shiny as well, but iodine is a non-metal who is very much shiny, isn't it? Iron is very much shiny. And if someone asks you like, they are brittle, they are not hard, so I think that diamond is the strongest natural substance, but that is a non-metal, but still it is very hard, isn't it? So there are exceptions, definitely. So what else? Yeah, so there are exceptions for all of it, so that is the thing. Okay, now there comes the metalloids. So metalloids are just like, they are not metals and not non-metals, so they have both the properties. So the metalloids, they share both the properties. They are just in between both the properties. So if we just think about the periodic table again, if you just go back to the periodic table again, so you'd be able to see here the red one over here, they are metals. The blue guys over here, they are non-metals. Okay, but the yellow in between them, they are the metalloids. Fine. So the metalloids are in between them, so they share both the properties. Fine. So you can see, you'd be able to see both the properties are shared there. So, metalloids exhibit some properties of metals as well as non-metals. So what are the metalloids? Boron, silicon, germanium, arsenic, antimony, tellurium. So you can see, you can just go back to the periodic table all the way to see what are the metalloids. So you can see these are the metalloids. Okay, the yellow ones. Fine. These are the metalloids. Okay. So I guess that's it for today. Okay, we are just going to go through some of the questions and we are done for today. Okay, so what is meant by a substance? Okay, let's see. It is a pure single form of a matter. A substance has a definite property and composition. Example is iron. Okay, so what is a substance? So they are saying that if this is a matter, if we have a matter are all the things we see around us. Okay, now a substance has a definite properties and composition, and it is a pure single form of a matter. Okay, so substance is like iron. Iron is a substance, so it is like a pure form of iron. So this is nothing but, you can say, so for iron, if I just take iron as a example, so for iron atom, element, molecule, and compound all are same, right? Understanding it, all are same. Okay, so better, we would rather say, so we would never say this atom that's if is a molecule, if is a compound, so better we say it is an element or atom. We can say that this is a substance as well. Clear? So I think we have gone through all these things. So that was all about it today. And what you have to do is, you have to, if you have any doubts, you have to just write it that in the forum. And definitely, I think we have enjoyed this video. And yeah, definitely keep on practicing the questions. And yes, we are going to meet on the next video as well. Okay. Bye everyone for today. Okay. Bye.